Am I audible to all of you? Just write in the chat box. Okay. So now I am sharing my today's presentation slides. So in the last class, we were going to discuss a question which is based on parsing, uh, and it is related to operator precedence parsing table. So this is the question, and we are going to parse a string. Uh, this is the grammar given to us. E produces E plus E, then E produces E into E, and E produces ID. So these are the three productions in the grammar, and this is the operator precedence parsing table. The operator precedence parsing table is between the terminals and the dollar. So this is the operator precedence parsing table related to the grammar. Then we are going to parse the string id plus id into id. So these are the steps which we need to follow in order to parse this string. So basically, the first step, we need to put dollar sign at the beginning and the end of the string. So just like that, we need to put the dollar sign at the beginning and at the end of this string. And in the next step, we need to put the the precedence between these operators. So all of us know that the dollar is having the minimum or the smallest precedence than any of the operators. So and id is having the greatest precedence or highest precedence than any of the operators. So in between every operator, we need to put the precedence sign. So like dollar is less than id, then id is as id is having the highest precedence, then id is greater than plus sign, and also id is greater than plus, then id is greater than into sign, also id is greater than into sign, and id is greater than dollar sign. So we need to put these precedence sign between uh, every terminal pairs. So all of you understand it? Just write in the chat box so that we can move further. Okay. So moving to the next slide. So now we need to scan this string from left to right. So from here we need to scan. So first we encounter the first id. So we need to select that I mean that operator which we need to take the less than sign, the operator in between. So this is the id is between the less than sign and the greater than sign. So we can treat this operator as the handle. As you already discussed, this is the algorithm step, that whatever the operator comes between the less than and the greater than sign, it is treated as the handle. So now this handle can be replaced by the production which produces it. So as ed, we have the production that e produces id. So whichever the production produces this uh, this terminal, then we can replace it with with that non-terminal. So as id is produced by the non-terminal e, so we need to replace this first id with this e. Now we are scanning the input again. now we encountered this id. So now this id is in between the left braces and the right braces, means less than sign and greater than sign. So this id is also treated as the handle in this step. Then we need to replace this or this id with the non terminal which produces it. So this e, so this id is replaced with this e. Now in the third step we encountered this id. Just a minute, just concentrate on here. I will be back in a minute. Now in the third step we encountered this id. So this id is comes between the left braces and the right braces. So it is considered as the handle, and we need to replace this handle with the production which produces it. So at last we got these uh, three non-terminals, and basically the two operators are the plus and the into operator are between them. But we know that in the operator precedence grammar we only concentrate on the terminals. So now the non-terminals can be removed, and again precedence relations can be inserted between pairs of terminals. So here the non-terminals e are removed from this expression. So only we have left only two operators, the plus and the into operator is there. Now we need to reduce these operators also. So now we know that plus is having greater precedence than dollar, and into is having always greater precedence than plus, and also into is having greater precedence than dollar. So now we need to here we get that into is in between the left braces and the right braces. So this into is considered as handle here, and now we need to replace it this handle with the production which produces it. So according to our grammar we have the production e produces e into e. So basically this into comes from this non-terminal, from e non-terminal. So we need to replace this into with e, and now we are left with plus. Now as you can see here, now plus is considered as the handle, and we have the production that e produces e plus e. So here also here also plus is considered as a handle, and now the plus can be replaced with e. But in the operator precedence grammar, as it as we are taking only the terminals, but at last here we are getting the non-terminal. So non-terminal can be removed from here. So at last we have this, the dollar is there. So that means our parsing is done successfully. So it means the string we are parsing with this operator precedence parsing table is successfully parsed with this operator precedence parsing table. And in suppose if we are not getting this at the last, then it means this string is not parsed with this operator precedence parsing table. Now all of you understand it, how we are going to parse it. So just write in the chat box, all of you understand it. Okay. So I am enlarging the screen. Just a minute so that it will be better for you. Now a question is given to you. This is the grammar given to you, and you need to construct the operator precedence parser of this grammar. So just try to form the operator precedence parser. The 3 minutes are given to you, so try it in these 3 minutes, and write in the chat box. If someone completes it, then write in the chat box. You need to first find the leading and trailing symbols of the non-terminals, and after that you will be going to construct the operator precedence parsing table. So such type of questions are basically comes in your exam, and it is of 8 to 10 marks. So use the algorithm of operator precedence parsing table algorithm for its construction, and also you need to use the rules for finding the leading and trailing symbols, which we already covered in our last lectures of operator precedence grammar. So last 1 minute. Now this is the operator precedence percent table, and these are the leading and the trailing symbols. So just compare your result in your copy with this answer. So basically, the leading and trailing symbols are based on the rules. And for construction of Poisson table, we have the first rule that if HI and HI plus 1 are the terminals, then we need to put the equal to sign in between the HI and HI plus 1. And if HI and HI plus 2 are also terminal, then we need to put the equal to sign in between them. So in our question, uh, you can see that at the places of HI and HI plus 2, we have the terminals. In the case of this production 1, here you can see this is if we consider this is as HI and this dollar as HI plus 2, then we need to put equal to sign in between them. And also if we consider the left parenthesis at the place of HI and right parenthesis at the place of HI plus 2, then we need to put equal to sign in between them. So that's why the equal to sign in the operator precedence Poisson table comes two times, because one time between the $2 symbol and one time between the left parenthesis and the right parenthesis entry. So as you can see here, in the operator precedence Poisson table, so unit we have a left parenthesis and the right parenthesis. So this entry is here we got the equal to sign, and equal to sign is also come between the dollar and the dollar entry. So this equal to sign is also here. Okay, so all of you understand it? Just write in the chat box so that we can move further. Just to go through the algorithm we already studied in our last classes of operator precedence Poisson table, and also the rules of for finding the leading and the trailing symbols. In order to construct the operator precedence Poisson table, it is must that you know the rules for finding the leading and trailing symbols. Okay, so moving to the next slide. So now next algorithm is for the function table. So this is the algorithm for constructing the precedence functions. So basically, these functions are somewhat different than the functions you already studied in C language. So basically, for this is the algorithm steps. So you need to just go through these steps. So for any terminal A, create functions f, a, and ga. So for any terminal, we have two functions, uh, fa and ga. So partition these symbols into groups. If a equal to b, then fa and gb are in the same group. So if two terminals are equal, it means that their functions like fa function and gb functions are also in the same group. Now the third step is create a directed graph whose nodes are the groups found above. For constructing this directed means we need to give the direction uh, where which is the source and which is the destination. So we need to give the direction here. So if there are two conditions, if a is less than b, means put an edge from group of GB to the group FA. Means whatever is greater, you need to move forward here. So here B is greater than A, so we need to go from GB to group FA. And if A is greater than B, then we need to put an edge from group FA to the group GB. So whichever is greater, you need to move from there. So here, if A is greater than B, so you need to move from A to B, and this is your direction, A to B. And if B is greater than A, then the direction is reversed. So the last step is, if the constructed graph has a cycle, it means no precedence function exists. So this point is very important. If you find a cycle in the graph, then there will be no precedence function. So when there are no cycles, collect the length of the longest path beginning from the groups of fa and gb respectively. So if there is no cycle, then this algorithm is having significance. If there is no cycle, then we need to collect the longest path starting from fa and gb respectively. Means we need to take the two lengths, one from fa and the second from gb, if there is no cycle. And if there is cycle, it means no precedence function exists. So these are the four steps of the algorithm precedence function. So just remember these steps. So now we are going to solve our previous question by using this algorithm, and let's see the difference. Now moving to the next slide, just remember these steps of the algorithm, particularly the step number 3 and the step number 4. So moving to the next slide. So this is our operator precedence table of the grammar we already discussed. Of our three production, like E produces E plus E, then E produces. This is our grammar. E produces E plus E, then E produces E into E, and E produces ID. So these are our three productions. So this is the Parson table we already discussed. So now we need to construct the function table. So which is of the form of this graph. So as we know that we, for every terminal we need to put two nodes. Like in the graph we have nodes and edges. So here we have four terminals, id plus into and dollar. So for every terminal, we need to have two nodes. One is of F node and the other is of G node. So just care has been taken that if you are taking the the G node of that terminal, then you need to take the F node of that terminal just consecutive at the consecutive place. So here we are first taking the G ID, so we are taking the F ID as well. So now just take the alternate way. Like if we are taking G here, like if we are taking G here, then we are taking G here, then the G here and the G node here. So just taking it in an alternative fashion in order to shorten your graph. If you are taking it on the same side, then the graph is very much large and it cannot be fit on the paper. Now we are going to just give the directions. So as you can see here, the this function is treated as f function, and the row wise function is taken as the g function. So this is the g function and this is taken as the f function. So now you are taking that uh, like we are taking as FID. So FID, like FID and FID has no relation, but FID and GID. So you have the relation that FID is greater than G plus. So here we have FID and it is greater than G plus. So we need to draw a directed arrow between the FID and the G plus. So as you can see, this FID and G plus. So this arrow has been drawn from the FID and the G plus. Now here we are taking the FID and the G into. So here also greater than sign from ID to into. So a directed edge has been drawn from FID to G into. So as you can see here, this edge has been drawn. FID is greater than G into. And in the same way, as FID is greater than G dollar, so a directed edge has been drawn. This FID is greater than G dollar. In the same way, we are going to draw all these edges. So in the second row, we need to draw the relation between the F plus and then the GID. So as you can see that F plus is less than GID. So in that case, we need to draw the edge between the GID which is pointing to F plus. So as you can see, where is GID? GID is here. So we need to draw a edge between GID and F plus. So the direction of the edge is GID and F plus. So in this way, we are drawing all the edges. So FID, now the second relation is F plus is greater than G plus. So it means we need to draw an edge from F plus to G plus. So here our plus is this, F plus is here, and we need to draw the edge. So this is our direction. So this has been shown in the graph. So in this way, we need to draw these all the edges. So all of you understand it? How this graph has been made from the function table, from the from the operator precedence Parsons table. And from this graph, we need to construct the function table as well. Okay, other students are are also understand it or not? Just write in the chat box. Only 4 students are only writing yes. Okay. So in this way, we need to we need to construct all the edges of this graph. So as you can see here, how many relations are there? As you can see, this is a 4 cross 4, means 16 entries can be possible here. But this entry is blank, this entry is blank, and this entry is blank. So it means we have 14 relations. So in this graph also you have 14 edges. which are pointing according to the precedence. Uh, so this is the graph which precedence. So this is the function table graph basically, and it is constructed from the operator precedence parsing table. So just remember this graph because from this graph we need to prepare the function table. So moving to the next slide. So according to the step number 4 of the algorithm, so if there is cycle, that then it means there is no precedence relation. But in the previous slide graph, there is no cycle in the graph. So we can make the function table. So as there is no cycle in the graph, then we can easily make the function table from that graph. So from the previous graph, we extend the following precedence functions. So now the function table can be made in this way. So we need to write the all the terminal symbols row wise. So this row has been uh, filled with all the terminal symbols. So here we have four terminal symbol, and this column has been filled with the functions. So basically we have two functions, f function and the g function. So now how we are going to fill this entry? So the 4 2 4 and 0, how we are going to fill these entries? So first we need to put the 00 sign here in the dollar entry, like the f dollar entry, and the g dollar entry will be put 00 here. And now we need to put these how we are going to fill these entries. So just to see, uh, just remember the third step of the algorithm. So the third step of the algorithm is this: if when there are no cycles, collect the length of the longest path. So in that case, we are going to collect the longest path beginning from the groups of FG and GB respectively. So now we are going to collect the longest path, which is going to begin from the FA and GB functions respectively. So now you are going to see that how we are going to fill the entries of the function table. So just check every entry, and we are going to check what is the longest path we can going to draw from here. So we need to fill the entry from FID. So FID entry, you can see that. So if we are going from this line, so just move, this is one, we are moving downward, then two, then 3. So we are going to end here, g dollar. So what is the length? 1 2 and 3. 3 is the length. And now we need to check whether the 3 is the longest length, or is there any length which is greater than 3 can be possible here. So we need to also go through the other path. Like if we are moving to this path, then this is the one, and now here from here we need to go here. So this is 2. So only 2, the length is 2. Now we need to also check that only these are the only paths which are starting from FID, or there are any other paths left. So we need to move this one, again that one, then we are moving downward, that 2, then from f plus we can also move here, then this is 3, and at last we can move here f dollar, then this is 4. So this is now the length which is starting from FID, the longest length is 4. So here we can see that only two paths is available, and now the length of the longest path which is starting from FID is 4. So we need to write the entry uh, FID. So from function F to ID we need to write like this, like F and G functions are there, and this is the ID entry. So we can write 4 here because 4 is the longest path which is starting from ID, FID. So now we are going to fill the entry which is starting from the GID. Now we need to fill the longest path here. So there are two paths which are starting from GID. So according to the first part, if we are moving downward, then now 1, 2 and 3. So 3 is the longest length. Now we are going to check that whether 3 is the longest length or other lengths are also possible. So we are moving that 1, 2, now we are backtracking now 1, and we can also move here. Now this and this we can also move here. So only 2 is possible here. Now we need to check from the other path. So this is 1, here it is 1. Now we are moving to here like 2, and now 3. So from this way we are going to find the longest length. So this is now 3 is here, we are finding this here. Now we are going to check whether any other paths are also possible, uh, which gives you the answer greater than 3. So you can move here like 1, you are moving this like 1, then you are moving this like 2, then you are moving 3, then you are moving like this, and you are moving like this. So here the 5 lengths are possible if you are moving in a zigzag way like this, this, this and this. Like, so 5 lengths are possible from GID. So 5 is the longest path, so you can write 5 here corresponding to G, and ID entry has been filled with 5. So all of you understand it. So we need to write the longest path starting from that node. So just write in the chat box. So here we are only just finding the lengths from the FID and the GID. So you need to also count the lengths from the F into G plus and F plus also, in order to fill the complete function table. So just we are going to find how we are going to. So if we are going to find the F into path, the longest path, then you can see that from F into what is the longest path, you can go downward like 1 and 2. So 2 is the longest path. If we are follow this path, then this is 1, this is 1, then 2, then 3. So this is 1, so we are moving to this 2, and this is 3. Like if we follow this path, and if we follow this path like 1, 2, 3 and 4, like this 1, then 2, then this we are moving this 3, and then 4. So 4 is the longest path, which is starting from F corresponding to into. So we can write in the cell F into 4. So in the same way we are going to find the G into, then G plus and F plus also. And once we find all the longest path starting from every node, then we can fill the our table. So we need to fill this table. So these entries will be filled. With these entries will be filled from the longest path, and always this the dollar the the dollar entries with the function are always put with 0, because always the dollar taking the inward function, and no edge has been going outward from the dollar. That's why it is taken as the 0. So this is the length of the all the paths. Like we need to show it that FID, which is the longest length. So this is the longest length. We already know that. So these are the, so 1, 2, 3 and 4. So that's how we are going to find that the longest length which is starting from FID is 4. And in the same way, we need to write that 1, 2, 3, 4, and 5. So this is the path we are taking from FID to F dollar, and this is the path we are taking from GID to F dollar. So from FID we have the longest length 4, and from GID we have the longest length 5. So what is the advantage of making the function table? So basically the size of the table is 2n. So previously we have the size as n cross n. So whatever the number of terminals, we have the table size as n cross n. So basically we have the 4 terminals. So our the size of the table is 16. So now the for by making the function table, we have reduced the size of the table to 2n. So now you can see that the size of our table is 2n, which is 8. So half so size of the table is reduced much more uh, by using the function table. So this is the advantage, but there are some disadvantages as well. So moving to the next slide. So the disadvantage of function table is, even though we have blank entries in the relation table, so we already have 2 blank entries out of 16. Only 14 entries are filled and 2 are left blank. But in the function table, there we have no blank entries in the function table. So blank entries are also called error. So the function table does not gives us the clear picture, or the errors which are present in the operator precedence parsing table. So hence error detection capability of relation table is greater than the function table. So basically the function table does not detect the errors. So for detecting the errors, we need to have the operator precedence parsing table. So this is the advantage of so this is the disadvantage of function table. But it basically, in terms of space, the function table is having advantage with respect to the relation table. So moving to the next slide, only 2 minutes are remaining. So just to consider these rules: if theta 1 and theta 2 are the operators, and if precedence of theta 1 is higher than that of theta 2, then theta 1 is greater than theta 2, because it has the higher precedence. Theta 1 is having higher precedence than theta 2. So we can write is theta 1 is greater than theta 2, or we can also write that if theta 2 is less than theta 1, because theta 1 is having the higher precedence. And if precedence of theta 1 and theta 2 are same, then this is our relations. Then if theta 1 is greater than theta 2 and theta 2 is greater than theta 1, if we are considering it as left associative, as you know that the plus into divide and minus sign all are left associative operators. So whatever sign comes first, it will take as the left associative rule. Means if we have a expression, and if plus is encountering first and minus is encountering second in that expression, then we have the relation that plus is greater than minus. And if in the expression minus comes first and plus comes after minus, then we have the relation that minus is greater than plus, because we are tracing the string from left to right, and it follows these operators follow the left associativity rule. Although they both have the same precedence, but they follow the left associative rule. Means whichever operator comes first in the expression, if by scanning from left to right, that operator is having the left more precedence than the second one. And in the same way, if theta 1 is less than theta 2 and theta 2 is less than theta 1, if right associative, and you know that the exponential operator and the equal to operators